jointly organized by AIU-VGU-AADC, Vivekananda Global University, Jaipur, and the Jindal Center for Global South in collaboration with Jammu and Kashmir Economic Association and the Cafe Economics. I welcome you all and extend a heartfelt thanks for your participation. Research analytics serves as a bedrock of social sciences, aiding researchers and scholars in demystifying complex social phenomena. Over these 10 days, we aim to dwell deep into various facets of research analytics, equipping each of you with skills to leverage data for impactful research. Today's session is on analyzing data using descriptive statistics and MS Excel. Dr. Naveed Ahmad Loan, an assistant professor of economics in the Department of Higher Education, Jammu and Kashmir. Dr. Loan has previously taught at Islamic University of Science and Technology and Baba Ghulam Shah Badshah University. He completed his PhD from BBAU, Central University, Lucknow, and Masters from University of Kashmir. Dr. Loan's impressive credential includes qualifying NET GRF thrice. He is being awarded as an ICSSR doctoral fellowship and publishing extensively in national and international journals. His research interests span monetary economics, social development, and Islamic finance. He has presented his work at numerous conferences, delivered special lectures, and is an editor of various reputed journals. He has also completed one research project of financial inclusion funded by ICSSR. In addition to this, he has guided many PG scholars, and presently 3 PhD scholars are pursuing the research under his supervision. With his extensive experience in social science research and adept use of statistical tools, Dr. Loan will guide us through the fundamental yet vital techniques of descriptive statistics in MS Excel. Dr. Naveed's session today focuses on how we can use this method to paint more precise and meaningful picture from our data. Understanding these techniques is essential not just for individual research but also for adding values to the collective knowledge in the social science. I'm sure today's session will be enlightening for all of us, and I encourage you to actively participate, ask questions, and engage with the content to make most of our learning opportunity. Once again, welcome to this workshop, and let's embark to this enriching journey together. Without further delay, please join me in welcoming Dr. Naveed. Sir, you may please take over.
Thank you so much, ma'am. Am I audible?
Yes, sir.
Let me share my screen first. And I've already shared one of the data file with Dr. Firdaus. I hope the participants may have downloaded and they are ready with their laptops, because today's session is hands-on training, and we would like to have a collaborative session, more interactive session. And before going to hands-on training, let me share my screen, and then after this brief presentation of 2 or 3 slides, we will switch over to hands-on. Is my screen visible?
Yes, sir.
Okay. At the outset, let me thank Vivekananda Global University, Association of Indian Universities, Jindal Center for Global South, Jammu and Kashmir Economic Association, and the Cafe Economics for their tremendous efforts and choosing such a wonderful topic having contemporary relevance, is all-time live for the researchers. Either they are at their early career in their research programs, or they are at the peak stage of their research, because understanding the methodological perspectives and analyzing the data in a better way is always need of the hour and is always live. So having the importance of this very workshop, and in line with that, this particular session that is basically on descriptive statistics and use of MS Excel becomes more relevant. In this paradigm, before going ahead with hands-on training, I would like to share with you 1 or 2 slides, because I have a presentation, detailed presentation on descriptive statistics. Because if we go on detailed presentation, what descriptive statics is, then we are not in such a position that we can make a session that is more fruitful. Mm, what I mean to say, to have hands-on training on how we can use Excel so that we can analyze the data, we can come up with results in a better way. Uh, I am here quoting Ronald Coase. If you torture the data long enough, it will confess. And basically, that is problem with majority of us. Because when it comes to research, the ethics says that we must be objective, but unfortunately, majority of us are objective, subjective. That means we all know the data can be tortured in several ways in order to prove a point. But as a ethical professional, we must know that data must speak the truth even when it doesn't fit our needs. That is the prime objective of going through this very hands-on training. And we as ethical, as professional researchers, must not torture the data up to the mark that it may speak what it may not have to speak. That is my humble request to all of you. Then here lies, termed lies, and the statics. Phrase that describes how statics can be used to support weak arguments or to mislead the people. Given this background, you must have got the idea what I want to basically share with you. Always try to be a bit ethical with the data because data speaks by itself. And in the contemporary era, but I personally feel that since the time I was in research, that is since 2012, I am in research, actually participating in research, but I have seen that we are in an era, since then, we are in an era of softwareization. That is, we love to know the software, how to run it, how to come up with results, and what we are basically missing, what we are basically lagging is how to interpret the data, what data actually speaks. And my personal experience says it is not important to learn the software, but what is important is to know what basically data says. To important is to know what basically data comes up with. In that very background, what I love to share with you that I already shared Excel file. We go on hands-on training and then come up with how with a basic MS Excel we can go up to the majority of researchers use either descriptive statistics or what we say ANOVA, chi-square text regression, correlation, or we can say we can go up to modeling, even linear programming and all that. All those techniques are available, or we can easily conduct all those modelings in MS Excel. And what I want to convey is we need not to go behind the softwares. That is, we not need not to have, there is no need to adopt softwareization. What is important is to adopt a particular technique and go with that and then come up with what data says and be loyal, ethical, and objective with what actually that data says. Without wasting much time, I would like to go directly in the Excel, and I request all of you, please, you all download that very file that I have already shared with you, and we will go hand in hand. And I would like to have responses from your side. I will proceed, and you accordingly reply. Are you getting or not? I would love to hear from you all. Now I am sharing my Excel file screen, and we will proceed with that. That will work much better if you people are okay with that. I hope majority of you people have downloaded the file. Hello. Hello.
Yes, sir, we have
Yes, sir.
downloaded. Yes, sir, we have done.
Okay, you kindly open that very file, and I will also switch over to that, and then we will go step by step. Is my screen visible?
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay, you kindly follow the steps. Basically, if you open the file on your laptops or desktops, you will see in the different sheets I have mentioned. First, descriptive statistics, then mean and standard deviation, histogram, resource histogram, correlation, regression, then chi-square, ANOVA, and all that. We will step by step follow all these basic descriptive statistics techniques, and I will help you people how we can basically describe our data or whatever data set you have, because I have shared that very file that will ease out our task. We will follow the same steps, and that will help you to understand the basic techniques of descriptive statistics and all those techniques that I have mentioned that I will try to cover in that very short span of time. Going with the descriptive statistics, basically descriptive statistics is very much important when it comes to data analysis. As long as you don't have idea about the nature of data, you don't have idea about the different paradigms of the data, you can't go with any type of modeling, either it is basic modeling, regression, correlation, or advanced modeling, whatever it is, indexing or linear, even linear programming, or any type of model that you want to adopt in your and basic technique that you are dealing or that you are conducting with your research is you always try to understand the descriptive statistics of the data. Basically, as long as your data is not normal, as long as your data is not within specific range, as long as your data is without outliers, you can't use good models, you can't come up with good results. So the basic and fundamental exercise that we are always doing with the data is to go with descriptive statistics. Given the data that is for 1 month, 1 year 2024, I have taken the hypothetical data that is sales in thousands. Like in January, you have 13,000 units had been sold out. Feb 18, then March 13,000 accordingly. You can go with this or you can take another, whatever is your choice. But better is to go with that. That will help us to go hand in hand. For conducting descriptive statistics or any of the advanced statistical analysis in Excel, please note that there is nothing like that you can have in a start, like in case of you have SPSS or in case of R or in case of Stata or eViews. There are installed commands and specific techniques through which you can calculate all this. You simply put a command in Stata and results come out. Here you have to do one exercise. Go on File, then go on Options. In Options, click Add-on. And here in the last, you see Excel add-ins. Click on Go. And you see there is Analysis Tool Pack, VBA, Hero Currency Tools, AVIS add-in, and Solver add-in. What you have to do, if Analysis Tool Pack is not highlighted, you have to tick this. Like this one, in case of mine, it is already highlighted. I have deselected. Now I will again select it and click on OK. Are you following me? You
Yes, sir.
kindly repeat this. You kindly
Yes,
repeat
sir.
this. Options. I will show you. Options, then add-on, and I will go here. I am deselecting because I will show you. If I am going on data, nothing is here like data analysis. You will not find anywhere data analysis in my toolbar. Now, File, Options, Add-on, go this. Then I am selecting Analysis Tool Pack. Click on this. Okay. Now, if you see under data here, automatically comes data analysis. Okay. Is it okay? Everyone is following?
Yes, sir.
Now we have to, our first step in the first case, we are trying to understand the descriptive statics of the data, that is for 1 year sales in 1 year from January to December in 2024. What we have to do, we simply click on data analysis. Here in data analysis, you will see it starts from ANOVA and goes up to Z test and all that. We will go step by step. Here we are interested in descriptive statics. Click on descriptive statics. Okay. And in descriptive statics, you will see a dialog box is coming. And here you have to put your input range. Your input range is basically now, that is the data, means sales in thousand month-wise. But you have to keep in your mind that when you are selecting, you have two options, either to select from first entry, that is from January to December, or you have to select from the title sales also. If you are selecting with the title, then you have to click on label in the first row. What this means, that whatever is mentioned in the first row, that means a label. You have to label, that is the title or the name of the variable, whatever you see. If you are not selecting these sales, I mean, if you are not selecting the row first, okay, then there is no need to mention the label in the first row. But I will always suggest to you to select from first row and then click on the label. That basically helps us what this descriptive statics is all about, of what variable this descriptive statics is. Are you following me? Anyone, please?
Yes, sir.
Yes,
Okay,
sir.
good.
Yes.
Good. Then output options, because these output options, if you are not going to select these output options, automatically it is new worksheet play. That means when you are going to click OK, the new output sheet will come and that will distract we from this very data file. What is important is click on output range and then click here. After that, you select particular cell. Click on output range, and after that you have to select the output range. That is a particular cell, like I am clicking and it is being highlighted. Done. Then go for this summary statistics confidence level, because we don't need what is important is we need summary statistics. Click on summary statistics and then okay. If you see, here comes your descriptive statics: mean, standard error, median, mode, standard deviation, sample variance, quota, skewness range, minimum, maximum, sum. Either the advanced software, that is SPSS, E-reverse, Stata, R, Grittle, whatever software you take, values comes the same in the same way. Simply you copy them and put it them in where you want to, either in Word file or in MATLAB, whatever you want to, or minute, jahan pe bhi aapko rakhna hai, you can put it there easily. This is the simple method how we can calculate directly descriptive statistics. I think whosoever is following this Excel file, they have done in the same way and the results are same. Is it okay?
Sir, few candidates are requesting to repeat the process once again.
Sure. Let me delete this. At the outset, I told you with regard to this analysis in Excel, what you have to do, you have to activate your data analysis tab. For activating data analysis tab, you simply have to click on file. From file, go to options. From options, you have to basically add on. You have to add some tool pack that is already installed and you simply have to like activate it. Click on add-on, go down in the right corner. Here, manage add-on and go. You have to here highlight analysis tool pack and then click OK. Under data, if you see here, automatically comes data analysis new, tool pack, that is data analysis. Now we have to calculate descriptive statistics. For calculating, simply click on data analysis And under data analysis, here comes a dialog box, and in this dialog box, there are various statistical tools that you can use while conducting this data analysis, starting from ANOVA to Z-test. But here we are interested in a descriptive statics. Click on descriptive statics. Okay. Then input range. Your input range is simply your data. As I already mentioned that when you are highlighting or when you are inputting your data, you must start from the first row where the variable name is mentioned. And here you have to click on a label. That means label in the first row. That means the first row of the data set or the input is basically the name of the variable. Second, you have to basically input, or you have to suggest, or you have to make your input suggestion to the Excel, that why you want to highlight or why you want to show your output, and that is output range. For this, you simply click on this very box and then go on specific this what we say specific area in the Excel. You simply click and that got highlighted. That means wherever you click in the Excel, there comes your output of what you are interested in. That is, here we are interested in descriptive statistics. That descriptive statistics comes in this E11 in Excel. Huh? Then comes here what you are interested. Here basically we are interested in summary statistics. Summary statistics, click on this and then okay. Simply here comes all your descriptive statistics, that is here. It is clear now?
Yes,
Is this
sir.
clear now?
Yes, sir.
Okay. Second is mean and standard deviation. Why I'm already we have calculated mean, standard deviation, standard error. Everything is being calculated here. Why I have repeated this? The reason is very simple. Here we have calculated directly using simple command and we have calculated. But in Excel, we have both the ways. We can use direct commands using your already installed tool packs, or we can go manually. That is why I have repeated this very, sheet. Here we can go manually and I will show you how we can calculate. Here, you know what mean basically is. Simply mean is sum of observations divided by number of observations. Here, number of observations is, here I have already mentioned number. That means count. And for that you have simply enter equal count. Count of what? Count of this. That means it automatically counts how many observations we have. 10. In the same way, count it automatically counts. These are 13 observations. For calculating mean, we know that mean is equal to sum of observations divided by number of observations. Here, sum of observations is with we people. Now we can calculate, insert entire row. We can calculate sum. For sum, you have two options. One is you simply write sum of what? Column group A students, yeah, group A people, that gives you sum equal to, you write sum, then you got sum of observations, you got number of observations. Is this clear to you? Is this
Yes,
clear to
sir.
you?
Yes,
Okay.
sir. Yes, sir.
Now we can calculate what we have to calculate? We have to calculate mean, that is sum of observations divided by number of observations, equal to sum of observation is this, divided by number of observations is this. Similarly, equal to sum of observations divided by number of observations. Now, this is what we call the manual way of calculating the average. This is time consuming, but you people must know how we basically calculate in a manual way also in Excel. Now we have one more method of calculating the same average, equal to average of this. If you see, we calculated manually, that is 163 is average, this. Now I am calculating using formula, that is equal to average again. In both the ways, your values are same. Either you calculate manually or you directly use formula, choice is yours. Always using the formula is very easy, but when you know the method, when you know what is the significance of mean, when you know how we calculate mean, then you have no issue of calculating manually also. But we have the what we call this technique of calculating, either is yours, but you must know how we calculate, what mean is, how we calculate, and what is its significance. That is very important. I think this is clear now how we calculate mean, and same procedure is being followed all descriptive statistics. If you see standard deviation, STDEV, standard deviation of group A, this equal to STDV enter. This gives you how you manually calculate and how you using the formula you can calculate descriptive statistics. And this is applicable for all these descriptive statistics, either it is range or is median mode, whatever it is, you can calculate both the ways. But important is you must know what these values mean or what these values signify. I think now how you can calculate descriptive statistics is okay with everyone. Is this, does this need a repetition or it is okay? Anyone, please?
Myself is okay, sir.
Yes.
Okay. Can we switch over to histogram?
Yes, sir.
Yes, sir.
Okay. Basically, when it comes to descriptive statistics, when it comes to playing with the data, when it comes to having information from data, there are two approaches. One is numerical approach and one is graphical approach. Numerical approach is like we have already calculated the descriptive statistics, and then we have a graphical approach like histogram and bar graph, whatever we have different techniques of describing or showing our data through graphical presentation. And one of the important and very much relevant in case of descriptive statistics or representation of data is that is histogram. And I think those who are using Excel, we always make use of these charts, 2D or 3D charts. And I would like to make this thing clear that charts and histogram is something different, because histogram is basically based on frequencies. And normally our data is not in frequency form, that is in continuous form. Like if we make the chart of this very data, like we normally do, and this cannot explain any information in a concrete way. And normally when it comes to histogram, what is important is generation of frequencies. And with the help of those very frequencies, that gives us a concrete idea about the data. What the data basically, what is the nature of the data, how data is being distributed, what type of distribution this follows, and for that we must have what we call the graphical representation in the form of histogram. And so my request is never to get confused when it comes to graphical representation of data with charts and histogram. Histogram is something different. I will show you and you will get clarity basically what histogram is. For histogram, this developing histogram of any of the data set, like I have taken the students, 26 students A to Z, and their grades, how much they have got out of 100. Like student A, 45 marks, yeah, 45%, student B, 48, student C, 73, and like that. Now we will convert this very information in a graphical presentation using histogram. Given this data set, again, switch over to data. Then data analysis. Choose histogram. But sorry, before proceeding to this, what we have to generate bins. That means we have to generate frequencies. What I mean to say, you type here bins, and then you go with your data set, and randomly you see your data varies. What is the minimum value? Minimum is around, that is in 30s, and maximum is in 70s. Fine. So we see our highest grade, yeah, highest marks if somebody has out of 100 is 100. And we will start from 10. Our frequency, these are like frequencies you have. 20, then go to up to 100. That means these 20 entries, yeah, the data we got for 28 students, we want to have only 10 frequencies, means students who are in the range of 10 to 20, 20 to 30, 30 to 40 are who are in the range of 10s, 20s, 30s, 40s, 50s, 60s, like that. There is some message. Sir, could you please slow down? Okay, sure. We have data set of 26 students. We want to generate the histogram. As I already told you, we must take a note that there is difference between the commonly or usually used charts and histogram. A chart that is here simply gives what we make input, yeah, graphical representation of actual data. But like I'm going to show you the histogram of, sorry, the chart of this very data set. Like this. And if you see, it simply shows the graphical representation of each of the 26 students. And having this type of graph does not signify anything concrete that we can interpret in a better way. But what is important is, as you people have already gone through descriptive statistics, where the importance of frequencies is very much important. And frequencies help us basically to concise our data. That means we make limits in this very range, how much data falls. And for that, what we call the bins. We have actually made 10 limits, 10, 20, 30, and we want to generate data for, sorry, histogram for this data. What I am going to do, data analysis, histogram, okay, input range. There are two ranges now. One is input range, one is bin range. Input range is our actual data. Again, I am selecting from grades, not from row 2. As I earlier repeated, always try to start from row 1, where you have basically your name of the variable, that is grades, grade. And then click on label. Basically, the first row that is here, grade, depicts what we call the name of the variable. Second is bin range, that already we have generated. Click here, then your bin range. Now, what you want? Cumulative percentage, you want output range. Click on output range, and then any part of the Excel that gets highlighted where your output comes. And finally, we don't need cumulative, we don't need sorted histogram, we need simply chart out output. Then click see. This is your histogram, and see the difference between what you earlier got and this one. And that simply means your maximum number of students who falls in this period is 60s. If you see here, here comes the frequency. Those students having 60% are 10, that is the maximum, followed by 50, then 70, and accordingly, in case of 100, you have 0. In case of less than 30, you have 0. That is basically difference between the histogram and the simple chart we are usually using. You can now switch, or we can copy this. What you want to paste, you can paste it. I think this is clear to you now. How we generate histogram in a better way in Excel. Is this clear to you?
Yes, sir.
Any repetition? There is some message in the chat box. Sir, please repeat this. Sure. I am again repeating. There is difference between. Sorry, please repeat. Okay. I am again repeating. There is difference between simple chart and histogram. Histogram is basically based on frequencies, and these frequencies give us actual idea, concise idea of the data, and that is more important, how we concise our data and get better information. That is the ultimate objective of analysis of data. For generating histogram, what is important is to generate bins, and there is no thumb rule. You can start from 20, 30, but the basic thumb rule, what I suggest to you for, go for minimum and maximum. If your maximum is, let us say, 1000 and your minimum is 500, you can put a gap of 100. That is your discretion, whatever this bill limit you can generate. That is, there is no thumb rule. But what is important is you must understand maximum and minimum. Then accordingly, you take your bin limit. Like we have maximum value in 70s, we can put here 80. Right? Sorry, we can put maximum limit 80. And our minimum value is in 30s, we can start from 20. There is no issue of taking 10 or 20. That is your choice. Now we start from 20 up to 80. Clear? Now we have these bin limits for the grades. Go on data, analyze, histogram. You have input range, start from grades, then click on label. Right? You have bin range that we have already taken, then output in this already selected, and chart. Here comes your histogram again. Clear? Clear? Is this clear now?
Yes, sir.
Okay, fine. Now we will switch over to one more, that is resource histogram. Basically, resource histogram is simply a chart. Here is no need of creating bins. You simply insert, go to charts, and here 3D chart. This basically gives you the idea of the data, what type of distribution of data here it is. It is not commonly being used in social sciences. That is why we will not make much efforts on that. That is simply insertion of what we call the chart you are usually using in data analysis. Now, one more important is that is correlation. Almost a majority of basic social science researchers are using this very what we call the correlation. As you see, correlation is basically as I've taken a snap and you see that shows how the variables move. Two or more than two. It may be more than two variables. We will go for simple correlation and the multiple correlation. And then accordingly, if you have already gone through descriptive strategies, you can go for multiple correlation as well. Here is the basic formula that is I have taken from some website. It has very well defined each and every value. R is correlation coefficient, then summation of this x minus x bar into y minus y bar, and then under root of these squares, sum of square of deviations. Here I'm not going to explain this. Basically, I am going to explain you the procedure, how we can calculate correlation. Again, calculation of correlation or anything in Excel is there are two ways. One is directly you make use of formula, or second is manual way. We will go for both the ways, and that will help you people understand better how we can make use of Excel. First, we will go direct method. In direct method, you directly go to formulas. Okay, you go to formulas, and in formulas, if you see, there are many formulas. More, you click on more, and here comes statistical. Engineering cube extra, we are dealing with statistical. So take your cursor on statistical, then correlation. When you see, here comes, I'm repeating again, correlation. Here comes array 1 and array 2. Array 1 is variable 1 and array 2 is variable 2. Our variable 1, that is x, right? Our variable 2 is y, array 2. We click, and if you see, here comes our correlation coefficient, that is 0.9780. That is, these are highly correlated because that is about 1. You know, the correlation coefficient varies from +1 to -1. That is direct method of calculating the correlation. Is this clear?
Yes, sir.
Sir, could you please show us again how to activate data analysis option? Sure. For activating data analysis option, you have to go on File, Options, Add in. Here, down the right corner, this last option is Manage and Excel add-ins. Click on Go. There comes many options. If your data analysis tool pack is not activated, then it comes like this. You simply have to click on and then click OK. If you check, here comes data analysis tool pack. I think this is now clear. Somebody has raised here the query, and this is now clear to him or her. Huh? Coming back to correlation, here comes the correlation coefficient using the direct formula. Or directly, you have to go on formulas, then statistical, then correlation, and array 1 is your first variable, array 2 is your second variable. Okay, sorry. Correlation, correlation, array 1, that is first variable, array 2, and here comes your correlation coefficient, that is 0.978, 698 around. That gives you. Is this clear? How we directly calculate the correlation coefficient? Is this clear? How we directly calculate the correlation coefficient?
Yes, sir.
Yes, sir, it is clear.
Okay. Now,
Yes, sir.
second method is manual method. How we can manually calculate the same? And we will cross check if our correlation coefficient, that is R, is comes 0.97 or not. For that, we have to follow the steps. But before proceeding, we need our formula is this. And this shows that we have to calculate x minus x bar, y minus y bar. For that, what is x bar and y bar? That is simply mean of x and mean of y. So we must calculate first mean x. And for mean x, I have already told you we have two steps, two methods. Either you can go manually or we can simply use the formula. Average of whole x variable. That is the mean of x variable. Again, average I'm here repeating average of y variable. This is x bar and this is y bar. Is this clear? Now we have to calculate xi minus x bar. That is xy is particular value of x and x bar is x mean. For that, what we are going to do equal to x minus x bar. Is this okay? Is this clear?
Yes, sir.
Yes.
Okay. But you have to keep here in your mind that your x bar value is fixed. It means all the 13 observations or 14 observations, this mean value of x, that is x bar, remains the same. When your any variable in Excel remains the constant, we have to put that variable within dollars. Clear? Now you simply drag. Here comes x minus x bar. Similarly, y minus y bar. But again, your y bar is constant. It is same for all the 13 observations. So we have to put it within dollars. Again, drag. Here comes y minus y bar. Is this clear? Is this clear?
Yes.
Fine. Now we have to calculate this x minus x bar into y minus y bar. Here I already created this one more column. That means equal to x minus x into y minus y bar. That all the variables are varying, so no need of putting the dollar. Simply drag, that gives you the value. Then we again need this x minus x bar whole square. That means x minus x bar whole square. That is x minus x bar into x minus x bar. Clear? Simply drag. Then y minus y bar into y minus y bar. Drag. Clear, clear, clear. Okay, fine. If you are following, please update me. Is this clear now? All the
Yes, sir.
calculations have been done. Now what we need basically, we need summation of x minus x bar into y minus y bar. X minus x into y minus y, that is equal to sum of this whole. This is summation of x minus x bar, this, huh? Clear? And then we need under root of summation of x bar into y bar. That means summation of, first summation of this, right? Then summation of this. This one is, if you see this one, this highlighted one, that is basically the numerator. But in denominator, we have simply calculated summation of x minus x bar, summation of y minus y bar. We have to multiple them. This into this, fine. Then square root equal to square root of this. Now you can calculate R. R is this divided by this. That gives exactly the same number we have got earlier, 97810, this value and this value. Is this clear? Any repetition? Is this clear to all, or I have to repeat this?
Yes, sir.
Okay. Means we are, there is, yes, okay, fine. Means there are two ways of calculating the what we call the correlation coefficient. One is you can use directly formula. Second is manual method that we were doing in earlier in our classes. There are both the methods in Excel. You can calculate correlation coefficient. This is clear to you?
Yes.
Yes, sir.
Fine. Now one more, that is a regression. And for that, we have regression equation. I'm not going to explain what regression is, what we are basically doing. There is simple technique of calculating the regression equation in Excel. For that, what you have to do, you simply have to go on insert, then click on scatter. Sorry. You have to select the data, insert, click on scatter. Here we have to change a bit because this scatter shows our data set from 0 to 160 x, and y variable it shows from 0 to 300, but our x starts from 110. We, for our simplicity, otherwise there is nothing wrong with this, we can double click on, we can double click on x-axis and right click on x-axis, then click on format axis. If you see on the right side, our x variable starts from 110. 110 is minimum and maximum is 150.
Kindly repeat regression again, if
Yes,
possible.
let me complete this, then I will repeat again. Okay. This is
Okay,
x.
sir.
Again for y, you go right click on this y axis, format axis. Again, your y data starts from 180. Minimum value is 180. Maximum value is 250. Then see, this is your scatter plot. And if you click on, right click on this very scatter plot, you see add trend line. After adding trend line, there is on the right side, if you scroll down, here comes display R square value on chart and display equation on the chart. Here comes Let me increase its size. Here comes your regression equation and your R square. That is what you basically do in advanced softwares, either AVivel, Stata, R, and here in Excel, you can do the same with a simple technique, simply adding the trend line and then adding R equation and R square. I'm repeating this again. You have two variables, X and Y, and you simply have to calculate the regression equation along with a regression coefficient. Clear? For that, what you have to do, simply highlight the data along with variable name, then go on scatter. You can, for you people, for clarification, you can also set the trend line here and you will see, you will come up with same regression equation. Simply click on this scatter, right click, then add trend line. After that, click on display equation and R square. You can also set intercept. No need of that. Then if you see, again comes your regression equation and R coefficient, that is same that was earlier. But you always try to present it in some best format. So better is always to click on both the axes. First on x-axis, click on format. Your data starts from 110 and your final value is up to 150, maximum and minimum. Similarly, your click on y-axis, right click, format data, that starts from 180 and goes up to 50, and that gives you better scatter plot, exact scatter plot. And here comes your regression equation, trend line, regression coefficient, and you can interpret the way we are interpreting the regression equation. Clear? Repeated. Is this clear
Yes,
now?
sir. Yes, sir. Yes, sir.
Fine. Now, this is how we basically calculate a regression equation, a regression coefficient, and correlation coefficient, correlation among the two variables, a regression, correlation, fine. Now, switching over to chi-square. Is this clear up to correlation regression?
Yes, sir. Clear.
Fine. Now, one more important test that is being used by social scientists generally, that is goodness of fit, that is chi-square test. And chi-square test, again, you have two methods, two ways of calculating the chi-square value, or to testing your hypothesis of is there any difference between significant difference between observed and expected values, and or otherwise. First, I will directly switch over to direct method, formula method, and based on that, we can come up with the results. And then we will follow the formal method. We can go step by step. Using the formula, you simply again have to go to on data, then data analysis. Here comes, or we can go directly in formulas, sorry. Formulas, statistics, chi-square, chi cumulative chi-square test, chi-test. Here comes the actual range. Here comes expected. And this is your chi-square value. Now, what is chi-square value of 0.4535 means? I'm repeating. formulas, go on statistical, then chi-square test, observed, expected, actual and expected, and here comes your chi-square value. Now, what this chi-square value means, because as you see in this Excel sheet, I have already pasted that there are two hypotheses. One, there is no difference between observed and expected. And another is there is, null and alternate hypothesis. There is significant, yeah, there is difference between observed and expected. Now, before going to this chi-square test, we always have what we call the level of significance, or what we say always the p-value. The what basically p-value is, the probability of doing the wrong. Generally in social sciences, we take p-value of 5%. That means up to 5%, if we are doing wrong, there is no problem with the data, or there is no problem with our results. That means there is the chance of 5%. There are chances of 5% of doing wrong, because we are in social sciences and predicting the social behavior is very much difficult. So the level of significance of the p-value of 5% means level of chances of doing wrong of 5% is genuine. That means if your value comes more than, chi-square value comes, if your level of significance is 5% and your value comes more than 5%, okay, like we have 45%, that is significantly more than what? More than 5%. That means we are simply rejecting. That means what we are rejecting, that there, or we are accepting otherwise, there is difference between the observed and expected. Or what we can say, we are rejecting this statement that there is no difference between observed and expected. We are rejecting this, or we are accepting this. Clear? So having the level of significance 5%, our chi-square value comes, that is around 45%. That means simply there is the significant difference between expected and observed. If you see observed and expected, there is difference between the two. If we hypothetically, if we see there is difference in all the variables, that is all the entries 1 to 6 when we're tossing a die. Yeah, when we are rolling a die. Now, we have other method of calculating this, and our hypothesis, rejection or exception of rejection of null hypothesis, there is other method. That is, we can again calculate it manually using what we call this Excel. For that, what we have to do, for that what we have to do, we have to follow the steps. Simply, these steps are, our formula is summation of observed minus expected whole square divided by expected value. If you see, I have here already mentioned that deviation, that means observed minus expected. That is, our observed is 89 minus expected is 100. Drag this. This comes your O minus E. Now squaring, that means we are squaring this. We are calculating OE square, then dividing this by your expected value. We got this, then we have to make the summation. That means sum of all these observations. That gives us this value. Now, here our chi-square comes 4.7. But when you are going through manual method, you have to go in what we call the table, chi-square table. And for that, you must have to check your degrees of freedom. That is, if you have here, you are tossing 6 times this die, rolling a die, that means you have n minus 1. Your total number of chances, that is 6 minus 1 is 5 is your degree of freedom. If we go on this chi-square table, I share screen. Here comes the chi-square table. Is chi-square table visible to you?
No, sir.
Wait. Okay. Chi-square. Is chi-square visible to you?
Yes, sir. Visible.
Okay. Now, this is the chi-square table. And in this table, if you see, our degree of freedom is 5. If you go column wise, degree of freedom 1, 2, 3, 4, 5. And our level of significance is 5%. That is 0.05. That is 1, 2, 3, 4, 5, 6, 7. Seventh column. If you see, against 5, your what we call the critical value is 11.070. 11.070. Clear? Now, your critical value is 11.070. Now, what is the thumb rule? Thumb rule is, or what is the procedure? Procedure is, if your critical value is greater than your calculated value, you simply reject the null hypothesis. That is the same what we have done directly. Whenever p value or this calculated value or chi-square value is greater than 5%, we reject. Similarly, here our critical value is greater than our calculated value, we reject the null hypothesis. The same way, like we had calculated the correlation, either the direct formula or we have calculated the correlation through manual steps, the results are same. Similarly, in case of chi-square test, either you calculate directly or you calculate this chi-square using the manual method, results are same. What is important is, in both the cases, you must know the procedure of what we call this interpreting the results, when how we can reject and how we can accept the hypothesis that we have proposed in case of any of the model that you are going to adopt. Is this clear to you now?
Yes,
Is
sir.
chi-square estimation clear to you?
Yes, sir.
Okay, now switch on to ANOVA. Again, there is one more test, that is t-test. Why I have not taken t-test? Because ANOVA is actually the advanced version of t-test, in the sense that when you have more than 2 means, we make use of ANOVA, and same procedure is being followed when we are going for t-test. So, as mentioned here statistical formula used to compare the variance across the means of the groups. Again, here is null hypothesis. Is there any significant difference among the means or otherwise? Again, we have proposed the level of significance 5%, or we can take 10%, 1%. But as I already mentioned, that in social sciences, generally we take 5% because there are chances of doing the error. We are dealing with humans, or we are dealing with what we call society. So there are the chances of doing the wrong, and the probability of doing the wrong is again 5%. At 5% level of significance, we are going for ANOVA again. For calculating ANOVA, we have taken the sales in quarter 1 of 3 brands, brand 1, brand 2, brand 3, named as X, Y, and Z. And we want to check that is there any significant difference among the means using ANOVA. Again, same procedure, go on data analysis. Here comes one-way single ANOVA, one-way ANOVA, single factor ANOVA. Your input range. Again, you have to keep in your mind that we have to start from row 2, where we have mentioned the variable name or brand name. Then click on label in first row. Again, output range. Output range, where we want to basically put our results. Here I highlighted it, and then click on this. Here comes your ANOVA result. Now, first one is leave it. This is simply the data information, number of counts, sum, average, and variance. Leaving it. What is important is second table. Here comes variation between the groups and within the groups. Between the groups, we have only 3 groups, and within the groups, it becomes 9. Okay. Now, here again, we have 2 methods of estimating or testing the hypothesis, null hypothesis. One is directly you check the p-value, and second is you check using the F table, F distribution table. P-value, when your p-value comes less than 5%, we simply accept the null hypothesis. And when our p-value is greater than 5%, we simply reject it. If you see here, the p-value is 0.009, that is less than 5%. So we simply accept the null hypothesis that there is at least, U1, U2, yeah, means of all are equal. All the 3 brands are equal. But another way of checking or testing this null hypothesis is going in the table. Here we have 2 degrees of freedom. 1 degree of freedom is between groups, and second is within groups. And the procedure here, we have calculated value, that is this 11.096, that is calculated value. Now we have to compare this calculated value. Here calculated value is that is this. Then critical value. Now that we have to check from the table. And how we decide this H0, yeah, null hypothesis, if critical value CTR is greater than calculated value, we accept the null hypothesis, and accordingly, if this we accept. And conversely, now switching to F table. Let me share again F table. F table. Is F table visible now?
Yes, sir.
Yes.
Okay. Now you have 2 degrees of freedom. One is between and one is within. Here, if you go horizontally, these are within. Sorry, between. If you go vertically, this is within. So this is between. Now we have 1 degree of freedom, that is 2, and another is 6. 2, and here if you go vertically 6, that is 5.14. This one. 2 and 6, your critical value is 5.14. Now, again, sharing my screen. Now, look, what is critical value? 5.14, and your calculated value is 11.09. Again, the same. That is the acceptance of null hypothesis, because, sorry, in both the cases, what we conclude that calculating the ANOVA, you have again two methods. One is to go in F table, or second is to directly decide the hypothesis testing based on your p-value. In the same case you had in chi-square test. If your p-value is less than 5%, you simply accept. And if your critical value is less than the tabulated value, you accept it. In both the cases, the results are same. What is important is, again, the Excel gives you the F statistics or ANOVA results or chi-square results. But what is important is the interpretation. Interpretation comes when you go through the basics of descriptive statistics. There is some message in the chat box. Fine. Asha, is this clear to you how you can calculate ANOVA using Excel? Anyone, please?
So repeat it again.
Okay, sure. You have data on 3 brands, Q1 sales, and simply you have to calculate the ANOVA. You have to simply check, is there any significant difference among the means within 3 brands that had been sold out in the Q1 in specific company or specific area in specific country, whatever the case may be. You simply have to go on again the data, and I am again repeating, this data analysis tool pack is not available. You have to activate it, and for that I have already shown you the procedure how you can activate this tool pack. You have to go on data analysis, and in data analysis you have to select ANOVA single factor, and You have to put input range. I am deleting this now, putting my input range. Again, I am repeating, kindly select along with your brand names, because those you have to label it. Otherwise, if you are going to, now this time we are going without labeling. You will check the results again come the same. Then we have to do, we don't have to, highlight the label first. Look, this time we are going without labeling. Results are same. Here, if you are going without this, then what you have to do, you don't have to highlight this. Your output range already here. I can again put it like this and then click on OK. If you see, results are again same, no difference. But what now comes, no mention of the brands, what column 1, column 2, column 3 defects. That is the difference between when you take, this time it simply shows column 1, column 2, column 3, but we don't know what column 1, column 2, column 3 is actually. Yeah, the paper or the researcher who is going to study your research paper or thesis or whatever it is, he doesn't know what column 1, 2, 3, as long as you are not going to explain it. So better is always to take all these brand names along with brand names and then put like this. We take along with variable name and then click on label. Then we will select some different area of output and put it like this. Yes. If you see now, here comes in place of X1, X2, column 1, column 2, column 3, here comes brand X, Y, and Z. This is how you can calculate. And again, the values are same. 0.09 is your, what we call the P value. And based on P value or cross-checking with your F table, you can calculate your F, you can decide either you accept or reject your null hypothesis of ANOVA. This is how we can basically calculate ANOVA, how we can go with regression, correlation, and histogram, then descriptive statistics, standard deviation, mean, whatever it is, you can calculate. Even you can go with advanced techniques, like you can go with what we call this linear programming. For that, again, you have to do one more exercise. That is, again, you have to go on. You have to add, and for those advanced techniques, you have to add something what we call the solver. Even you can add AVBus add-ons in it. Here you can add solver and click on this. Again, here comes, if you see, some more regression, sampling, histogram, moving averages. Here comes.
Sir, that screen is not visible, sir.
Screen is not visible. Okay. Sorry. I am again sharing. Is this visible now?
No, sir.
No, sir. Your screen is visible, but it is freezed.
Okay, wait. I'm not able to resume it. There is some issue from IT side. Kindly resume my screen, please. I'm clicking on it. It is not resuming. If someone is from IT, please. Is
Sure, sir. We'll try to
please,
connect with.
please, you resume it. What
Yes.
I'm saying is that these are some of the basic techniques you can do with the help of Excel. And for these techniques, there is no need of going for what I initially told you, softwareization of. You don't have to become the software engineers. You have to become the data analysts. You must be in such a position that you can analyze the data in a better way, interpret the data in a better way. So better is to focus on understanding the techniques of data interpretation and try to stop sharing. Okay, stop share. Now I have to again have to share. Now it is visible.
Yes, sir.
Okay, fine. So what I was sharing with you, that this data tool pack has extensive uh, statistical what we say the tools that you can use in data analysis. If you see from ANOVA, exponential smoothing, frontier averages, then comes your moving averages, rank percentile, and all the tests are here in what are being used in basic uh, data analysis in social sciences. So my suggestion is to understand this Excel in a better way, and that can ease out your research work in a better way. If someone has question or query, you can stop me and you can ask what you want to ask.
Sir, can you explain chi-square once?
Sure. Basically, when it comes to data analysis in Excel, you have two approaches. One is you go through this tool pack, right? This here comes your different, testing options and different models you can use in your data analysis. Second is there are some inbuilt formulas. Here comes the formulas. And what type of formula you need? If you click on, here comes the summation, financial, logical, text, date, time. We are here concerned basically this time with statistical. Here comes all the inbuilt formulas that are in Excel. Fine. And if you'll go again on the chi-square table, formulas, statistical, here comes chi-square test, and actual and expected, observed and expected. Observed means actual, and expected means 100. Right? Here comes your chi-square value. If this is less than 5%, then we accept, otherwise we reject. Then second method is manual method. In case of manual method, basically we calculate this formula, observed minus expected whole square. Our observed are this row 3, our actual, expected are row 2. We simply subtract this row 2 minus row 3, there comes these values. Then square, we multiply these two times. Then we have to divide it. Observed minus expected divided by expected. That is what we are doing here. This divided by A, this expected. Here comes 1 to 1 divided by 100. All these have been divided by respect to expected values. There comes the then summation, because ultimately we have to sum it, summation of this, and that comes 4.7. And here in this method, we have to compare critical, so this critical value and calculated value. If critical value is greater than the calculated value, we simply reject the null hypothesis. That is what we have already got through direct method. Because our this chi-square value is greater than 5%, we simply reject it. This is how we basically calculate chi-square in Excel. Two ways, direct as well as manual method. Choice is yours. You go for this or that. I think this is clear now.
Yes, sir.
Yes, sir.
Any other question, please?
Sir, in social science research thing, sir, if we do basic descriptive statistic analysis, is that fine, sir? Or advanced analysis also is required, sir?
This is basically somehow not the objective question, as per my understanding, because there is basically the dramatic shift in some of the subjects. Like if I say in economics, there is the quantification is basically quantification, or the data-based evidences are much more relevant nowadays, are much more trending as compared to theoretical. Or having advanced models in economics are now much more relevant as compared to having the basic descriptive statics. But what is important is what type of objective you have and whom you are basically going to suggest, whom you are going to basically, with whom you are going to share those very results, suggestions, interpretations. Like I am sharing one of my personal experience. Recently, I was conducting research. I had a project funded by ICSR. They categorically suggested that there is no need of using any specific model. Simply come up with calculations through descriptive statistics, because that was their objective to understand the policy from basic numerical points of view. If you have some study, that is, you have to forecast, you have to make forecasting for 30 years, 40 years. You have to go for forecasting techniques. You can't go with simple descriptive statistics. Or if you have to model that, or we can say if you have to, you have a longitudinal study, or you have a data that is time series data, you have no option other than to go with time series modeling. If you have the simply understand the cross-sectional data, your basic descriptive statistics is going to work. That basically depends upon the objective of the study, what type of statistical technique you have to use. And then important is how you are justifying your data, how you are interpreting your data, and how you are torturing your data, and torturing in an objective way. That is very important. And I don't think anyone can answer you should go with descriptive statics or advanced modeling. Basically, that your study or your data or your objective ultimately suggests you what type of modeling, what type of data analysis you are supposed to go with. That is my point on it.
Thank you, sir.
Welcome. Any other question, please? I think you have all got this Excel file, and you can do exercise on it, and this will ease out your basic analysis techniques and may help you in your research process.
So very good evening, sir. May I ask a question?
Sure.
Sir, I'm in data collection phase, and after this, I don't know what kind of analysis I have to do. I'm actually researching
Your
in
voice is not clear. Can you please type in the chat box? Your voice is not clear.
my voice is not clear.
Your voice is not clear. If you can please type in chat box.
Okay, sir.
Any other questions?
As long as he is going to type, you can ask.
Yeah, we can address some other questions.
Sure. Somebody is asking how to develop data interpretation technique. Basically, sir, I am asking how we can interpret a data. That is what I was basically telling. It is not the result that is very important. It is basically the technique that you have to understand. For example, we have calculated R square, and we have calculated the coefficient of regression. Okay, for that you must you must know what R square is and what is the coefficient of the variable, or the variable X means. That means what R square is means this shows the accumulative power of impact or the explanatory power of your independent variable. As long as you don't know what is independent variable and what is difference between correlation and regression, what is difference between dependent and independent variable, how they are correlated, we can't say there is something we can say ready-made that you can help us to interpret the data. Basically, you have to understand the statistical techniques from theoretical point of view, and then only you can interpret data in a better way. Coming up with results, basically when it comes to softwares or basic MS Excel, what is important, what you like in computer language we say garbage in and garbage out. You make your input, output comes, but what is important from that very input, what is your task, what is as a researcher your concern is to have the understanding of the data, have the understanding of that very model theoretically, then only you can interpret that very data. That is my point. Means you have to understand these statistical techniques theoretically first, then go with softwares or whatever packages you have. What type of data analysis I have to apply? Exploring the effects of, yes. That is not only your question, but everybody is asking this question, sir. I have data and I have to, what type of analysis I should go? No one, any of the data analyst expert, I'm not the expert, I'm still learning, but what I can say that no one can suggest to you that this type of data technique or this type of model you can adopt. Because as long as you don't understand your data, as long as you don't understand your objectives, as long as you understand your data in a better way, no one can suggest to you, you go with regression, you go with correlation, you go with WAR model, you go with ANOVA, you go with chi-square. No one is going to help in this. First, you have to understand literature in a proper way. Second, you have to understand your objectives and the data in a better way. Then only you can go with particular model. This question is not only asked by you, but majority of the researchers, budding new researchers are asking this question. What type of model I am going to use? Sir, I am going to give you a data, kindly use a model. No one is so expert that he can use the model of the data set, because we can use result comes, but we don't know what is the linkage between your theoretical underpinning and the data you had collected and the data I am analyzing from my personal point of view. So what is important is be ethical, be objective, and don't be subjective in analyzing and interpreting the data. So how many data I have to collect? I think this is with regard to sample size. How much? This must be how much.
Yes, sir. Yes, sir. Yes.
Okay.
I'm sorry about this.
Again, there are various formulas. How much sample size one should take. But before proceeding to sampling, we must know the characteristics of a good sample. There are the few characteristics of a good sample that must be representative, that must be chosen scientifically and all that, what type of probability you have adopted. Again, no one is going to suggest to you, if you have a population of 10,000 and that very population is totally heterogeneous, all the 10,000 people are totally different from one another. You can't go with a sample of 9,000. That is not going to give you a good result. In that very case, if you okay, in that very case, you have to take maximum number of population, because your population is heterogeneous. If your population is homogeneous, you simply take a specific amount that specifies your demand. I think these questions, like Bhagirath sir has rightly said, these are not relevant to me, but still I try to answer because I am dealing with something different. These are my suggestions. I may be wrong. You can, again, my email is there. My contact number is there. lonenaveed@gmail.com. My contact number I am typing here. You can call me directly. We can discuss on it. My contact number is here.
Sir.
You can call me directly. No
Thank
issues
you.
at
If
all.
you can give your contact number, sir.
I have
Thank
put
you
it in
very
the
much.
chat box. You can call me directly. No issues at all.
Thank you, sir. Thank you very much.
Thank you
Any
so
other
much,
questions?
sir.
Welcome.
Sir, a kind request. Can you just stop sharing the screen? And I will request
Sure.
all the participants to please put on the camera so that we can take a group photo before I conclude.
Is it okay now?
Yes, sir. A
Sure.
humble request to all the participants, please put on your camera for a group photograph.
Done.
Just a minute, sir. Thank you so much, sir. Sir, that was a wonderful session, and you have very patiently addressed all the requests, all the queries we have solved twice, thrice. We have shown all the processes. So, Dr. Naveed, I'm very thankful to you. Here we come to the end of fifth day of 10-day online workshop on research analytics for social science. I would like to thank our organizers, Vivekananda Global University, Jaipur, AIU-VGU-AADC, the Jindal Center for Global South, OP Jindal University, the Jammu and Kashmir Economic Association, and the Cafe Economics. I would like to extend my thanks to the participants for being so much involved in the entire session. I would also like to thank my dear friend and colleague, Dr. Bhagirat Baria and Dr. Firdos Malik for giving me this opportunity to be part of this research journey. Thank you so much all. We'll be meeting for the next session tomorrow. Thank you.